exercises, do them now because it's a lot of writing today. Okay. Basically, we are going to be using these in proofs coming up. And so these are all key points. They can all go on a help sheet. After you write them down, type them up on a help sheet, yes. As one particularly intelligent student mentioned earlier, you learn better when you actually write something down, and that is why I have you do this. Plus, if me and my advanced age can do it, so can you.
Your advanced
age.
My advanced age.
A way of saying you're old.
Corresponding angles. Postulate. Here we go. If lines are parallel, then corresponding angles are congruent. It's an if-then statement, yes. If lines are parallel, then corresponding angles are congruent. Of course, to have corresponding angles, you need a transversal, right? Just lines parallel by themselves. There's nothing there because there are no angles, right? So you do need a transversal to cut through them to get corresponding angles. But if you know the lines are parallel, which again represented by little wings or V's or triangles through the lines, then corresponding angles are congruent. Alternate interior angles theorem. If lines are parallel,
good to write this every time.
yup.
We like it.
Then, oh, it's a little bit different because this time it says alternate interior angles. Alternate interior angles are congruent. If you fail to write these down or you are abbreviating to just shorten it up, you are only proving that I'm stronger and more fit than you.
No.
So,
That's your ace, buddy.
write it out. If I can do it, you can do it.
I think you should.
If I can do it, you can do it. Alternate exterior angles theorem. If lines are parallel.
Right through everything.
Oh, this one's different. Then alternate
Lines are parallel.
exterior angles are congruent.
I'll
Wow.
pre-fire this one too.
No shortcuts.
This one's different at chance.
No shortcuts. You are only proving my superiority if you do a shortcut.
Arm wrestle is the strongest person in high school.
He
Honestly,
went.
arm wrestle the weakest. No, win.
He's got that.
He's got dad's strength.
Yeah, that's right. And you also
That's
have
actually
I'm gonna beat that in the next one. I thought it's called
Consecutive interior angles theorem. If lines are parallel.
consecutive interior angles are congruent.
Oh,
Oh,
gosh.
God.
Oh,
no,
gosh.
they're supplementary! Oh my gosh, we just that's
The one you decided to
Oh my gosh, one time.
Consecutive interior angles are, what are they, Gus? Supplementary.
It didn't do it. What's an indent?
Oh my god. That just hurt.
If lines are parallel.
Look at Mario.
Mario, Chance. Did you get this down, Chance?
Yeah.
Word for word? All of it?
Yep.
No abbreviations?
No abbreviation.
All right.
Lines are parallel.
Ate it?
Does that say supplementary or complimentary?
Supplementary.
You need this
Supplementary. Okay, questions on any of these?
Oh, it's converse now.
All right. What do we know about the converse of things?
If not that, wait, no.
If not that, then not.
Nope. Nope. It's the other way around. If that, then this. So the difference between the postulates and theorems just wrote down and these are that if corresponding angles are congruent, then the lines are parallel. So this one goes the other way. Okay? If you have parallel lines, you know corresponding angles are congruent because of the corresponding angles postulate. If you know that corresponding angles are congruent, you can then conclude the lines are parallel. So it goes both ways. You can use parallel lines, known parallel lines, to conclude angles are congruent. You can also then use congruent angles to prove lines are parallel. And that's where the converse comes into play. Okay? So it's basically the same thing, just reversed, because one proves the other, and it works both ways. Okay? It works both ways. Yes?
I thought the converse was false.
Unless we're dealing with remembers the conditional statement, the if and only if. Okay? If it works both ways, it's biconditional. It works forwards and it works backwards. I didn't name it, but I said we get back to that later. Here's an example of that. Okay? Alternate interior angles converse says that if alternate interior angles are congruent, then the lines are parallel.
I just put like the first letter of every single word.
Honestly.
Yeah.
How
do you spell the first letter?
I am superior, more fit, more sigma than you.
Yes, results, you go to the gym.
I don't have to. I built my own gym.
In what?
Could I catch you at Dunkin' Donuts?
Because no offense taken from that. It's pretty easy.
Schultz, what's your bench?
Huh?
What's your bench?
1 rep max.
I always use the buddy bench. It's my favorite one.
What's your squat? What do you squat?
Next one! Alternate exterior angles converse. If
I bet you can squat too.
alternate exterior angles are congruent, then the lines are parallel. Let's just say, Tatum, you don't get to be ranked number 48th in the world in Mario.
Oh my gosh, nobody cares about that.
How much grease is in those thumbs?
Punch grass.
That's like something
All muscle right here. All muscle.
Punch grass.
And
Do you play Pokemon?
do I play Pokemon? No, I do not.
Or even Disney? Like, I don't think
I
I don't
don't
know
think I
anything
know.
else besides that.
I used to play that.
Consecutive interior angles converse.
If consecutive interior angles are supplementary, then the lines are parallel.
If consecutive interior angles are supplementary, then the lines are parallel.
First thing we're actually learning.
At the bottom.
Can I just star all of this?
Parallel lines.
No, you need to double star all of this because that means it's really
No,
stupid.
1 star meant to dumb. 2
Right,
star
this
means
all
like.
is
I think the double star
Really
means it's dumb. I
stupid.
think
One
we
star's
double starred
dumb.
symmetric.
Star's
One star is
really
One star is important, double star is dumb.
Three stars is good.
Yeah. Transitive property of parallel lines. So we know what the transitive property is, right? Now we're applying that to parallel lines. Anyone have a guess? Apply the transitive property to parallel lines. Where transitive property on its own says if A is B and B is C, then A is C. When we apply that to parallel lines, if A is parallel to B, those two vertical lines like that is the geometric symbol for parallelity. Okay? So if A is parallel to B and B is parallel to C, then
It's not even learning
C
stuff.
is parallel to B.
A is parallel to C. Okay? If you have more than one, like if you've got 3 lines here,
And this is also
A, B, and C, with a transversal cutting through all of them, okay? If you can prove that A is parallel to B, and then prove that B is parallel to C, that means that A is parallel to C. Indeed. Evan!
Are you giving us homework?
No.
Don't ever say that.
No,
There's
because
no
I was gonna write something on the homework line.
Any questions on what we just wrote down?
There's a part 2.
Okay. So, as a very wise student recently said, the more you write something down, the more you learn it. So I actually have a new blank page with all of these things on it. We are going to rewrite them. I'm just kidding. Happy.
Nope, one star means it's
I knew it right away. You picked
If
up a
AB
random
equals
sheet of
AB,
paper.
it's
If
star.
it's stronger, then you should
So,
go up.
Okay, your homework.
No.
What?
No.
Oh.
This
What
is.
I don't know how to
This is also do this thing.
What is that?
What is this?
What is?
So, this objective,
Each one?
don't.
this objective on your test is worth 16 points. There's going to be 16 angles that you need to find based on parallel relationships. I'm not kidding. So, it's really, folks, you're making a bigger deal out of this than it is. Okay?
Stuck to algebra.
Because if you know these relationships that we just practiced yesterday and just wrote down today, you're not having to write any proofs. But if I ask you for example, what is this angle right here?
114.
How do you know that?
Vertical angles.
Was that challenging?
Yeah.
No, if you know, if you've been paying attention to these angle relationships, linear pairs, vertical angles, now corresponding, all those things,
Ron, stop playing.
okay, you know that it's 114 degrees. Okay? What is the one right below that? And how do you know?
66.
How do you know it's 66, Luca?
It's the linear pair of 114.
Luca, instead
on
of
the
just
right
saying you
side, and
can't
then
do
vertical
this,
angle at
let's
the bottom.
gain confidence that we can. You can do this. Okay? Luca, I'm sorry, please say that again. This is 66 here, and how do you know that?
So basically, 114 is like linear pair to the other side of that G thing, which
Yeah.
is 66 because that's equal 180. And then you can use a vertical angle thingamabobber to like vertical angle 66
Yeah.
on everything.
This is essentially what you did in the homework for today, only a lot bigger and a lot more angles. Okay? So far we used vertical angles, linear pair. Right? 9 of those are new. Okay? We've dealt with those before. Let's pick another one here. What is
And top left. Yeah, give me one.
let's do this angle here.
Wow.
The one I marked in green, raise your hand if you can tell me what that angle is. Please raise your hand. James.
71.
And how do you know that, James?
Vertical angle.
Vertical angle.
Okay? How about this angle here? Give me 2,
What angle?
66.
the one right here.
14.
Not 66.
114.
No,
No,
James.
114.
Okay?
40.
No, it's not.
Ow.
Just how do you know how
That
many
is
lines are?
Give me,
It's not.
Is it now? Is it now?
Oh, I see it.
Oh, it's 43.
I see it.
Okay, I'm done.
Why is this not thrown? It's
Oh, wait, I saw
53.
Evan, your hands up first. Go ahead.
Okay, now I'm done.
53.
Incorrect. Hugo.
Where does it say the lines are parallel?
I did forget to tell you that these lines are parallel here. Sorry. And these are parallel here.
Oh, I already.
My and B,
What about
Mine.
what about
Yeah, I already seen that.
E and G are parallel as well. Yes.
Oh, wait.
I
I
was
thought
lying.
Parallel to that.
it was in here. It's 43. Wait, no.
Wait, no. It is.
Thank you.
When you think about it.
Evan.
Can I say the answer to the one I got wrong?
Yes.
43.
43. Why is this 43? Evan, give me one of 2 ways that we can determine that is 43. Gus, quiet please.
A triangle equals 180.
Okay, so once we got these 2 angles here, 71 and 66, we can use the triangle sum theorem to complete that triangle and know that these 3 angles have to add to be 180. Okay, that's one option. What's another option that we could use to say that this is 43 here?
Alternate interior.
Alternate interior angles. We've got the 43 here with B, the 43 here. These are alternate interior angles. That works as well. So, like I talked about, the more tools that you add to your toolbox, the more options you are going to have in determining what these angle measures are. Okay? So each red dot, the two diagrams below, the one on the left focuses mainly on the triangle sum theorem. There are no parallel lines to worry about there. And same thing with this last one here. All the lettered angles you need to solve for. This one is also very triangle sum theorem based. Vertical angles, things like that. Okay. My hint on that last one there is look for all the triangles you can. Like you see the obvious triangles here on the end, but don't forget you've got a triangle here, right? That could help you. Don't forget you've got a triangle here that could potentially help you. Don't forget you've got a triangle here that could potentially help you. Every single triangle, the degrees have to add to be 180. Okay, so look for those triangles, not the obvious ones. They'll help you too, obviously. But look for the non-obvious triangles. You might need those to complete the puzzle. Okay? So, these are due tomorrow. You've got 6 minutes left to work. All it comes down to, folks, is relationships. You define geometry on day 1 as being the study of relationships. You know the relationships, you get the answer with pretty simple math. Stop talking? Okay. That's all your math.